Hello and welcome back to the Rockwood Academy. This is the complete guide to teleport, and this is a workshop number 2. That means that for the next 40 minutes, roughly, we will be taking a look at me, work through a GitHub document as available to everyone to work through in their own time, to show and share some of the cool features of teleport. Today, we are focused specifically on application access. We'll cover what that means as we work through the scenarios. But first, I really just want to get started, show you what we're working with today, and get started with the first task. These are live workshops. That means you're more than welcome, if you're watching us live, to put questions into the chat, say hello, anything you want. Just reach out and we'll do our best to get to that as quickly as possible. Now, let's get my screen shared. If this is your first workshop, you can find all of these courses at github.com/rockcode-academy/courses. You will find a directory there called teleport-complete-guide, and this is 6-application access because this is part 6 of the teleport course. Now, let's scroll down. So I am, for this workshop, and I guess probably for all future workshops, going to be using the Acme/Let's Encrypt certificates with Teleport, which means there are domains and DNS records configured. I have done my best at the top of this README document just to tell you what those are so that you can replicate this in your own setup. If you are cloning this directory locally and working through it in your own time, I would encourage you to do a search and replace for rockcode.sh and replace it with a domain that you have access to the DNS records for, just to avoid any strange errors as you continue. I am using Linode for today's virtual machines. So there is a Pulumi, a small Pulumi project available here in the directory. So you can just run Pulumi up as long as you've got the right credentials for Linode exported in your environment. And this is going to spin up a 2-node setup with just Ubuntu 20.04. All right. So my DNS records are all created. I'm not going to run through exercise 1, but I will confirm that they do exist by running a dig t.rockcode.sh. I have a wildcard configured so that I can, and hopefully it can do anything. We get the same IP address, and I set up for my worker node W1, which has a different IP address. So that looks exactly like I expect. It means that when we install Teleport to these machines, it's going to pull in the Acme certificate. Now, all of these workshops are standalone, so we're going to kind of quickly fly through just the creation aspect. And again, just to make sure that everyone is comfortable with this and you know what you're doing, it does not hurt to run through the setup a couple more times. I'm going to start with SSHing to my control plane node. There we go. And we shouldn't have teleport here. This machine has only been spun up around 30 minutes ago. There's nothing on it. This is a very generic and boring Ubuntu machine. And we're just going to follow all the commands. So the first thing I'm doing is I got bit with this in the first teleport workshop by not setting the host name. I expected Linode to do this through the labeling. If we take a look at the automation here, we do add a label which seems to set it on the back end for the Linode portal, but doesn't set the host name of the machine when you SSH in. And then the host name was just localhost, and it looks really crap when you start trying to explore teleport through the UI or through the CLI. So we're fixing that today. The first thing we do is set the host name that we want it to be. Now, I'm going to copy and paste all the boring stuff. We're using the teleport Debian and Ubuntu package repository. What confused me and scared me prior to jumping onto this live stream, not recording, was that Teleport 8.0.0 has been released. It seems to be pretty new, but I don't think, based on what I've seen in the release notes, we should run into any problems today. Fingers crossed. Let's give that a second. Now, the next thing we want to do is configure this. So on the first workshop, we ran into a little issue around insecure certificates. Now, I'm not going to go into it in detail about what the problem was because I decided just to record a tutorial, which should drop or be available by the time you watch this. Fingers crossed. And it's just because Teleport needs access to the root CA to be able to trust those certificates. They're shared, and most of my tests were in containers or using Kubernetes, where I had volumes that shared those root certificates across the different agents. But when I did the workshop, I used Linode for the first time and ran into some problems, and that those certificates weren't being shared across the different VMs. Of course not. We can just omit all of that and use the public DNS records and real certificates from Let's Encrypt. So what we do here is we say teleport configure, which is just going to tell teleport to generate base config. We did look at this in the first workshop. The parameters we can pass are just, hey, let's enable Acme. Here's the email address for the account or the name that I want associated with the certificates. Here's the name that we wish to use, and -o just tells it to save it to a file. So if we pop over here, we've not got a return on that last one, so let's just do that quickly. And we are getting 8.0.0 again. That wasn't an accident, now just a thing. And we'll give that another moment. There we go. And we should have access to teleport version, which we do. So we run this configure command and we can see that it has created a config at the location we expect. And this is the pretty standard teleport config. We've seen this now a few times. What's important here is that our proxy service has the Acme, the YAML has the Acme key with enabled to yes and an email address to attach that certificate. All right, so I'm happy with that. I'm just going to go ahead and start teleport. And if we jump back to our instructions, that was the next thing. We've got the example configuration, which you should see. And now we are going to continue on from what we also did in workshop 1, which is use static token authentication. This is not something I will encourage in a production environment, but for these workshops, it's a great way to get started quickly. We will have a best practice video where we talk about doing this in a nice, safer fashion. However, what we want to do is grab this tokens and add it to here on the off service. We'll fix the indentation because that's all we ever do. And what we're saying here is that we want to have a bunch of tokens available in the off service that allow anyone with access to that token to authenticate on a proxy and node basis. I'm going to add one more and fix my README, because we're going to need it later, and it saves me doing it there. Here, oh, app proxy node. I have fixed it locally. I just haven't pushed it. There we go. Even better. So proxy app and node. We want to allow the proxy service to connect and speak to this teleport cluster. We also want to allow the app service to connect and speak to this cluster, and the node service we want to allow to speak to this cluster. And the token is raw code-workshop. I see Russell has joined us. Hey, mate. Russell is on the Discord. I've been talking about my audio and camera problems that have been affecting me for a week, but today were really bad, so I'm hoping that I look and sound all right. Feel free to give me a thumbs up if you don't mind. I'm going to continue regardless. So we have our raw code workshop static token available, and we're going to need that when we have other virtual machines, nodes, bare metal, whatever, connect our teleport cluster. So let's save that and jump back over to our README. It should look something like this, which we now have. Oh, I was doing it through here. There we go. And now we can create our admin user. This is the user that we are going to use initially to set a few things up within our cluster. One thing is different from workshop 1, and is that we no longer have access to roles equals admin with teleport 8.0.0. It's now broken down into you have to use editor and access. So roles admin is gone. I'm going to have to record that, re-record that entire workshop, but that's probably for the best anyway. And we're going to add logins root so that I can have root access to each of the nodes within the teleport cluster. And we click our link, and we're going to sign up. Now I have done some tests on this domain, so I'm going to reuse my password. There we go. Password, and I'm going to have to rescan and get my second OTP down here. And that should allow me to sign up. There we go. Now, if I zoom in, we'll see that we have access to the teleport UI. We have one node listed here. Things are looking good. Okay, now we want to join the cluster. We can SSH onto the worker node. So I'm just going to split this terminal. L root worker1 rocco.sh. And we'll copy these commands like so. So we're setting the host name again, adding the Ubuntu or Debian repository, and then installing the teleport package. All right, install. Now I am providing the config for this, but essentially we're telling Teleport that we want to go and speak to this auth server, which is our control plane node, t.rocco.sh. There's the auth token that we added as a static token. We don't need the auth service on any of the worker. Russell, audio is fine for me, and I can see the difference between your t-shirt and hoodie, so I see the line is good. Awesome. It's a win. It's rare that I'm getting them these days. Okay, so we got the auth service disabled. We don't need that for things that are joining the cluster. The auth service runs on the first node, and then we enable the SSH service because we do want to be able to SSH onto any of these machines. So I'm just going to copy these two commands, drop them in, and we should now have, if we browse back to Teleport and hit refresh, drat. All right, debugging issue number 1. So what we expected to see there was on our teleport UI is that we would have the control plane node and one worker node. We didn't get that. It means it's potentially a problem. And it's saying that it is not again. Yeah, you look okay. All right, I'm not going to fight this time. So this did not happen during my tests. I'm just going to fix it later. So let's do vim, secure, restart, teleport. Oh yeah, that changed the unit file, so we will need a daemon reload, start teleport, or restart, sorry. And if we do a journal flu, yeah, no. Okay, so my certificates, I think actually we're fine. What's happening here is, when I say my join token is not valid. So let's see what we're dealing with. See, it doesn't matter how much you test this stuff, does it? Certificate is cool. Let's encrypt. That's perfect. Rockload workshop. Rockload workshop. Okay, let's see if we have any logs here. Cannot join the cluster with role proxy, token error, not found, off go. Okay, so I've configured, right, okay, gotcha. Let's stop teleport. And let's just blow away the teleport directory, and I'm going to remove that in secure because I'm hoping we don't need it. I think I didn't restart teleport after adding my token, my static token. So let's do teleport. Make sure our teleport service is still running. And let's try this again. There we go. It has joined the cluster. Perfect. I was nearly about to go down a rabbit hole of debugging that I had absolutely no need to go down. However, restart teleport after you change the configuration is very important. Don't make that mistake. Phew. All right. Now we're going to move on to exercise 5. We're going to take a look at the debugging application. This is just something that Teleport provides so that you can understand how their proxy service works, how it's modifying or mutating the HTTP request, so you can see the headers, and it also does some really cool stuff with JSON Web Tokens and certificates that allows you to be able to consume the credentials being passed through the proxy service within your application. And one of the really cool use cases here is if you're using Teleport with a GitHub authentication provider or any of the SAML-based authentication providers like Google, AWS, Microsoft, etc., is that you can pull in that user data and the roles so that you can then use that and pass it on to all of your internal administration or backend applications. And we're going to see if we can take a look at that. Something I've done different this time with the workshop is just provide the solutions for each of the exercises. So if you just want to copy and paste the code, you can. But what we're going to do in this workshop is kind of try and find the answers, which is going to be weird because I kind of know them. But we're going to go through the documentation. Like I want you to walk away from this knowing that the documentation is there, how to consume it, and the way that you would find these answers in a real world situation. So what I've said here is that Teleport ships with a debug application that dumps some environment variables for you to inspect. And we want to enable this application. We're just going to go to Teleport docs. And if I do debug, that's not the right one, is it? Dumper. Yeah, that's something else. Do that later. If I do dumper, you know what? Doesn't matter. My favorite page is reference. Go here, click on config file. Everything you can turn on is commented and documented in this file. So there's not, it would appear, and I haven't really searched for it previously, but there's nothing in the documentation about this debug application. But I do know that it's there. We want to play with it. So we go to the reference, we go to the config, we can search for debug, if I could spell. And what we see here, and I'll zoom in, is the first hit, which is great, is that, boom. Well, if I highlight it, you can't actually read the comment. Teleport contains a small debug app that can be used to make sure application access is working correctly. The app outputs JWTs, or JOTs, I believe we're supposed to pronounce them. So it can be useful when extending your application. That means consuming this authentication and not rebuilding it into your application when something is already doing it. So what we want to do is to enable this is find the app service in our Teleport configuration and add a debug app equals true. So that's just my systemd logs. So we're going to go to our teleport.yaml. We'll go to the app service, which we don't have. All right, okay, we need to configure the app service. So we can just come in here to app service, enabled, true, and we know that we want debug app equals true as well. We can save that, and I'm just going to cat it, and we'll compare it to what we see in the documentation to make sure we're getting what we expect. So app service, enabled and debug app, true. App service, enabled, yes, true, I think. I believe both work, we're about to find out. And debug app, true. So what we can do now, restart teleport. Make sure that we have no errors by popping into here. It doesn't look like we have anything. If it fails to parse the config, in fact, you get a pretty quick warning about it. And in fact, why not let's just break it? Let's say enabled equals fluffy kittens. If that doesn't break it, I'll be surprised, but let's go for it. Well, that's the YAML thing. Interpreting it as true, isn't it? It's funny. YAML. Okay, so let's leave that as true. Let's just add a fake setting. True. Restart journal. There we go. Pales parsing the config file. YAML on Marshall errors. Line 40 field fake setting not found in the type. So omitting the weird YAML accepting any value as a true or truthy value, you get really good feedback when Teleport is not happy with your config. So we'll just restart that. What should happen now, and in fact, do we talk about it here, is browse to the debug application. So we believe we've enabled it. And the way that we can confirm that is to come back to the portal and click on applications. And you'll see that we now have access to the dumper application. Now, what I like about application access on Teleport is that when we set the app service up, is that it uses wildcard DNS to actually give resolvable names to all of your applications. So you can see we can use dumper.t.rawcode.sh to actually just browse to this application. So if I just do dumper.t, and now you'll see there was a whole bunch of redirects there. So what happens is when we go to that web page, it's checking to see if we're logged into Teleport. It makes a few calls, gets the certificates, approves them, and then when it's happy, spits you back out to the application that you actually want to see. The dumper application here is just showing us the HTTP request stuff. So we can see we have a GET request. We can see the host. This is the proxy host. We do have the X forwarded for information down here. So if you've worked with HA proxy or Nginx in this configuration, you should be relatively familiar with these headers, or I guess most load balancers as well. We have accept stuff, which is pretty common. We've got access token here, and we've got our teleport assertion here. There's a whole bunch of stuff here. Let's jump back over here. So the last thing we want to do here is just, we want to decode this token. I actually want to dissect and understand what I have access to. Now, we haven't configured this teleport with any enterprise level authentication, right? GitHub, Google, etc. So I'm not going to get a whole lot back out, but you can imagine how that would be consumed. Next week, we do have a tutorial on configuring Teleport. So in Teleport open source, you get the GitHub authentication module for free. So as long as you have a GitHub organization with some teams, you can use that to integrate and log into your Teleport instance. But for today, we're using the local user. So I'm going to copy my Teleport JWT assertion, which is just the same as the access token up here for the record. We're going to go to jwt.io. This is like the de facto site if you're ever doing Jot stuff and you need to be able to debug why it's not working. Just go here because it has this thing where you paste it in and it will give you all the decoded headers, payloads, and the signatures. Now, if we know the private key, we can drop it in and it'll tell us whether this is signed correctly or incorrectly. Not really worried about that right now. What I'm really wanting to emphasize and show you is that we have the expiration time, we have the issuer, which is just our teleport here, so t.rocco.ch, and we have the roles, the username, and the subject is the same in Jotland, so you'll often see sub and username together, and the same value. But we can see the roles. We can see I'm an editor and I have access permission. These are the roles that when I did the T-control, teleport control, I don't know how to say that, users add, we said these are the roles we want to give these users to. The teleport allows you to define your own roles and throw in more metadata to there. We will have an episode, we'll have a workshop and a deep dive into RBAC in a couple of weeks' time, but you can see how we're getting this information. So if you can validate the Jot and the signature, you can trust that the information you're getting back in this Jot payload can be carried and passed on to your application, and you can have a really cool authentication model integrated with Teleport. Sweet. That was relatively without hiccups. Now, if we take a look at our solution, that's exactly what we did. So on the teleport server, we modified the teleport.yaml file. We added debug app true under app service, which looked like this. We restarted teleport and we are done. So let's try and do something a little bit more interesting. Let's install Nginx onto our teleport server. We'll add Nginx as an application to the teleport cluster. We're then going to go in and modify Nginx to only respond to requests on the private IPv4 address for the server, or even just 127.0.0.1, whatever, entirely up to you. And what we should be able to do is actually just confirm that Nginx still works through the application access, but will not work through the node's public IP address. Cool. So let's do an apt install Nginx. And if we browse, we'll give this a couple of seconds to finish first. %, come on. It's like a software development project where my teammate says it will take an hour. 3 weeks later. I'm guilty of that too, actually. There we go. So now we installed Nginx on the control plane. So we can't actually browse to it right away because this is our teleport server. So what we're going to have to do is come into our Nginx configuration.conf, find the server block. Oh, it's going to be in sites available, perhaps. Yeah, okay. Nginx, sites enabled, fine, default, pop down. And I'm just going to modify this to run on port 8080 on 8080. I would suspect Nginx hasn't started yet, so we don't have any logs. I did. But let's just do a restart Nginx. And hopefully now we can do t.rawcode.sh port 8080. No, HTTP. It was about time something went wrong. I think that's just being silly. Let me grab the IP address of this machine. Port 8080. HTTPS. Yeah. What was happening with the t.rawcode.sh? Not important. Anyway, we have an Nginx page here. So our mission is to add Nginx as an application to the teleport cluster. So we're going to go to the documentation and we're going to try and work out how to do that. So we can click on application, access guides, connect applications. And if we pop down here, it's going to walk through some of the stuff that we've already done for today. You know, adding tokens. Now you can use short-lived tokens for the application proxy process that you can run. We're going to configure it straight into the teleport.yaml for now, so we don't have to worry about that. And if we come down to starting a application with a config, now because this is a server process and we have all of this stuff available, is that we've already added app service and debug true, is that we could just grab this syntax here for providing a list of applications to expose from this machine and modify it to suit our needs. So we can modify our teleport.yaml. I'm going to have to do so much re-indenting here. So we've got apps. Let's try and get rid of some of the comments for now. I'm going to remove anything that's optional. It's all optional. This is all you need. So we need that to align. There we go. So we say apps, we give it a name. I think it would be fair to call this one Nginx. which is available on this local machine on port 8080. So we can just use localhost 8080 and we save this. So you haven't seen it working yet, but being able to expose things from the machine through the config is really, really easy. Just needs the name and a URI, and Teleport will handle the rest. We can do a system control restart teleport. And if we take a look at the logs, we should see things are still happy. We got our, oh, we kind of missed it. Where'd it go? There we go. This info line here, apps first in at 60. So we're now running an app proxy server here. And if we pop over to this and hit refresh, we now have our Nginx application here. You can see the DNS name has been generated for us, nginx.t.rocko.sh, and the labels. These are added by Teleport, just saying how does this application get added to the configuration. So let's just copy and paste this. We can also hit launch. I guess it doesn't really matter. It's going to do the authentication dance, make sure that we have access to this application, and now we can browse to it via nginx.t.rocko.sh. Now, there's something I haven't shown yet is what happens if we do that in a private tab? Well, what should happen is we get the Teleport login. We cannot use that name. We cannot go through the application proxy service without being an authenticated Teleport user. Very cool. Okay, the last part of this exercise is, well, okay. Sorry, well, the second last part is, okay, we don't want the public to have access to this. So you can see here we go through the Teleport service, but let's go through the node IP. But there's the node IP. Yeah, we did open that, and I can close this one. And we don't want this available. Anyone that has it, the node IP can browse their application. We're considering it relatively sensitive at this point in time, so we don't want that to work. Okay, so we can modify our default Nginx thing here. What we can say is listen. And I can just remove that, right? Who's actually doing IPv6 anyway? But now we can say listen on localhost only. Hopefully, oh, teleport Nginx. Hopefully I haven't broken this. Looks all right. And if we do a curl localhost 8080, we get a response. If we pop over to here, the IP address one, we have lost it, right? This Nginx application is no longer publicly available. And the last part of this exercise is, well, is it available via the Teleport proxy? And the answer is yes. Perfect. So that is how you take an application running within your infrastructure, you bind it to private interfaces to remove it from the internet and expose it through Teleport using the really great application authentication proxy. Sweet. Russell, I just tried that. Cool. I hope it worked. All right, exercise 7. So let's do this slightly differently now. Let's try and take, Nginx is great, but one of the most common use cases I have to use this specifically, and I'm assuming everyone is the same, is that Grafana is something that usually has access to a lot of monitoring and observability data. We run it on public interfaces because it's easy, but at the same time, we probably want to restrict access to it, depending on what we have there. So we are going to install Docker on this server and then pull the image and run it. And we're going to use Docker port publishing that is bound to the private IPv4 or the localhost address. And then we'll add this to Teleport. And the one twist we're doing with this one is just to show off some more application features, is that we can modify that DNS name that has been generated for us whenever we add the application. So here I'm doing gnt.rocko.sh or g.t.rocko.sh. All right, now whenever I need to install Docker, I go to get.docker.io and I grab this. So we take off the -o and just pipe it straight to bash. I think we just need to give this 30 seconds and then I'll be able to pull the Grafana image. Did we look at the solution for the last one? There we go. So the solution, we pretty much did exactly this. We did an apt install Nginx. We added Nginx with the URI here, although I was actually using port 80, not important. And then we listened on the private IPv4. Actually, I used 127, but I could have used the private IPv. And then we did confirm that it still works. Perfect. We're still waiting on Docker just now. Won't be too long. Oh, and my ferret is awake. Okay, cool. We have Docker. So let's do a Docker container run -rm -background -publish port. And I'm going to be very specific here. And when we use the port syntax with the IP address, it's just telling it the interface to listen on. We also want to run. Is it just called Grafana? Or is it Grafana? Yeah, I think it's Grafana. I could have looked at the solution, but I'm trying not to. Yeah, there we go. Grafana. Grafana. I think it's just that. Let's see. So what we're going to do is we'll pop over to the. Oh, I closed it. Grab the IP address again. On port 3000. And nothing works. Good. If we do a container ls, we should hopefully see a happy container. We do it up for 19 seconds. Compassionate swirls. Cool, I'll take it. If we do a curl on localhost, then we see we actually get a response. So Grafana is running in a container with a very specific publish port to the local interface. It is not available to the external world, but we want people that we have trust with, that are authenticated with Teleport, to have access to this application. So we're going to continue as we did with Nginx, and we're going to go into our application config. We're going to add a new app. Call this Grafana. The URI is localhost 3000. Now, what we said, well, in fact, let's just get it running first, and then we'll change it. Restart and teleport. So what should happen now is I should be able to, because I know how the naming structure works, is browse to https grafana.t.rockcode.sh. And after a little bit of an authentication dance, we should get the login page for Grafana. Looks good. But the exercise said, look, we don't want it available on grafana.t.rockcode.sh. Perhaps people know to check for Grafana on subdomains, or we just have another reason for one to live elsewhere. So how do we control this DNS name? Well, let's go back to my favorite page in the documentation. Reference. No. Setup reference. Config file. We can pop down to the app service, and we'll see that we actually have all of the fields that we are not using being commented on to tell us what to do. Now, we can tell it to skip insecure certificates if we want. If we're running something that has self-signed certificates on our server, which is quite common for private stuff, especially if it can't pass any of the ACME certificate requests or process. We can modify the public address, which we are going to do. Labels and commands, we can obviously play with later, and there's some redirect stuff that we can talk about for applications such as like WordPress that do a whole bunch of redirecting based on whether you're authenticated, trying to get to the admin portal, some of the assets or do internal redirects to. You can handle all of that. But right now, all we want to do is modify our teleport.yaml, change the public address to g.t.rockcode.sh, restart teleport, and we'll pop over here. We'll change this G to a T. There we go. Oh. Again. There we go. I think it's admin, right? Yeah, new password. I don't need to configure that. It worked. Okay, let's pop open the solution, make sure we haven't missed anything. So I did install Docker with curl bash. My run command was pretty identical to that, which is good. And we used a public ADDR to make sure that we can control the naming of our application. Okay, so we've got a couple more things to do. What if we want semi-public access? This is an extremely contrived scenario that I'm going to reuse on Nginx and add an admin page. But you can use teleport and your web server to restrict access. We got with Apache we have htaccess. With Nginx we can add location blocks where we can just say actually you don't have access to this from certain IPs or without certain headers, authentication, etc. So we're going to try and set that up. It won't take us too long, but our secret application is that we need Nginx installed first. In fact, did I say? Yeah. We're going to do this one on the worker node this time. Okay. I haven't mentioned it in the exercise, but I'm pretty sure I'm meant to, so I will update that. And I'm sure the solution has a quirk that I want to cover. So we're going to do it this way. Okay, so let's jump over here. We're on our worker. We don't have Nginx, so I'm going to do apt install Nginx. The next part of this is that we want to set up our secret admin page, which I'm just going to create an HTML file in the web root. We're waiting for that 1% again, aren't we? I wonder what it's doing. How big are the man pages for Nginx? If that's what's actually stalling it. Although I must also say, these are really small nodes. These are the nano core ones, so I'm actually not throwing too much power at this, which is probably why it's taking a little bit longer. All right, there we go. So here is my admin page. In fact, let's go to www HTML, cat admin. There we go. Wonderful stuff. And restart Nginx. Yes, if it didn't start automatically, for sure. Okay, so let's confirm W1 raw code. H. It's not. Yep, there we go. There's a page, and we can just browse to admin.html, and we get our really secure admin page. This is not what we want. Okay, where's my to-do list? So we want to modify the Nginx virtual host or site, whatever you want to call it, to block non-local traffic to the admin page. Okay, let's do that. Enabled. Here's our default. We pop down here. And we can do location admin.html. Rather than look at my solution, I'm going to Google it. Well, yeah, there's my search somewhere. There we go. this is how you find the answers to stuff. When you don't remember off the top of your head, we go to Google. And I'm pretty sure it's just allow and then the cider. Allow. Let's just try it. That's the only one I clicked on. All right, okay. Allow 1 to 7. Not 1. Yeah, I think that's it. Let's restart it. Not yelling at me. Yeah, okay. And let's have a look. Yeah, it didn't work. All right, we're looking at my solution. Ah, I forgot to deny all. Because it's middleware. All right. So Vim, Nginx, states enabled, default, local. Restart. All right. So let's. There. Perfect. So we've blocked admin.html. We still have access to the home page. Now we're doing this for very superficial. We expect the request to come from the local machine. That works all right in this scenario. Russell has lost access to his admin page. Dun dun dun. We're gonna fix it. So yeah, this works really well. Having that deny there, it's just a really simple way of restricting access to certain components. Wildcards work really well for Nginx and Apache, so you can really make this work where you have something that is public, 90% of it, maybe 50% of it, but there are components of it you're like, actually, I really don't want that exposed. Maybe it's a legacy application, you don't want to extract it out to a new thing yet. Like whatever your scenarios are, this works really well. And you can do this through anything that has layer 7 visibility. So even if this was in Kubernetes, rather than like an Nginx deny, you could build this into a Cilium network policy or whatever. So lots of different ways you can do this. But now what we want to do is regain access to this service. So hello, welcome. Thank you for joining the workshop today. Okay, so now we need access back. Now, I'm going to show you how it doesn't work first. And that you'd be very tempted to come into this and add our app service. Enabled true. And you would say we have an app that we want to expose through the teleport cluster, which has a name of admin with a URI of HTTPS. Oh no, sorry. HTTP localhost. And I didn't change the port, so this actually is running on port 80 and saving that. Now, of course, I even attempted this the first time. However, there's a bit of a situation, and that if we do a system control restart teleport, is that it crashes and we get some errors now. So it turns out that we can't expose applications in this way with this node configuration. Teleport, if it's not running the auth service and the proxy service, cannot run the application service on the node. You actually have to go a slightly different route, which is to use the teleport app start command, like so. So this runs application proxy that works in just this mode and allows you to export your applications, and you would run one of these for each of your applications you want to do. Now, I'm not going to do it just now and create a unit file and all that. We just kind of want to get this working. But we could do an app start, and we know our token is rawcode workshop, and we know that our auth server is t.rawcode.sh. And now we just need a name, which is admin, and a URI, which is HTTP localhost. Maybe I don't need the 3080. Maybe I do. Oh no, I've a broken teleport, which we need for the tunnel. Teleport happy? Teleport is happy. Okay, so let's come back to this. Maybe that's there. You're going to make me look at the solution again, aren't you? So it's saying that it can't hit my tunnel. Is my teleport running? Yeah. All right, let's just look. So I did document this here that when running teleport process as an application proxy, it's much easier to create a unit file, which I would encourage you to do. The issue for the thing that I mentioned is here. So app.start has exited, and someone from teleport has chimed in to say that this doesn't work, and you need to run the proxy service and app service in separate processes, which is fine. You can see that they have off service no here. So now we need to do a little bit of tidying up. So if I pop over here, here's my start command. Did I get something wrong? Oh yeah, 443, not 3080. Because we have a TLS version of our thingy running. Okay, that worked better. Do I need to change the command? Nope. Great thing about copy and paste. Okay, so that was the exact same command. I just got the port wrong. So it's teleport app start. We give the application a name, the URI to find it, a token, and the off server. That's now running. It's quite happy. So we're going to pop over here. You can see our Grafana, and now we have our admin. Let's hit launch. Authentication dance. Maybe. Oh, actually, I found this earlier. I didn't work it out. Let's try one more time. Admin.t.org. Oh no, it worked. Okay. I had trouble with the admin prefix. It wasn't resolving, and I could actually, like, when I ran dig admin.t.org.sh, it just wouldn't resolve at all, but only admin. That appears, that was just a temporary thing. So now we have our application here, and if we go to admin.html, we have forbidden. That wasn't expected. Let me make sure I got my rule correct. I'm just going to open a new thing. Nginx is enabled default. So what's my I just want to make sure that .0 we could be coming across the network. So we'll do this. I'm going to restart my application. No, I wanted to restart Nginx. That's the wrong host. Restart Nginx. And there's a really good way to debug this if it doesn't work. There is a rewrite log true. I think that's right. No. Rewrite log. Yes. Nginx rewrite log. On. So close. There we go. That if we can now come to here and monitor our error log, we should see if we still get a deny why we got the deny. So let's force the deny through W1. Yeah, this is me going to the node directly. So that should be from my public IP address. We look here. Our client 82 has been denied, which is what we expect. And if we come through admin.t, we're still being denied. Okay. So it's coming over the IPv6 address. We can fix that. So let's just make one final modification here, and we're actually going to allow one tail. There we go. Now, coming through the teleport authenticated proxy, we have access to our admin page, but the public world does not. I will update the workshop README just so that the correct thing is there, and this already is. No. Okay, cool. So I can get that fixed. But that's a really cool application and your usage for the teleport application access. I really love that semi-private public thing. Just leveraging Nginx, Apache, anything like that to block the things that we don't want people to have access to. So we're just going to take a look at one more thing, and then we'll finish up today's workshop, which is, well, actually, what if I need local access and I don't want to have to go through the teleport system? Can I use tcontrol to be able to do this? And the answer is yes. So we can do a tctl auth, and that was my old name from workshop 1. We're going to authenticate against tctl auth server. There you go. I think I got that wrong in the last workshop too. Oh no, I'm using the wrong command, aren't I? Help, I have no idea what I'm doing. TSH off. Why can I not remember anything? Login. There we go. Proxy. Okay. .sh is going to ask me for my username and my password. Sweet. Let's grab that from here. Code teleport copy and my OTP. Second. Oh, I've only got one there. I'm going to have to grab it from this browser. There we go. And I probably copied the wrong password that time because I was using the wrong one. So password OTP. I haven't seen that before. I am going to delete all of that. And try that one more time. Do I need the whole thing? I don't think you do. I think it just wants the domain name. Yeah. It already adds that. Oh, crap. All right, let's try again. Don't let me down. Password. OTP. Ah! Just in case, we're going to add insecure. In case I'm not sure. The joy of doing things live. Address. Okay. We are running teleport 8. I wonder if because my client is older. Yeah, there's 800 there. We'll try this. If this doesn't work, I'll pretend to go through the process of what should work. Again, we shouldn't need insecure because we're using less encrypt certificates here. Our proxy is t.rocco.sh. Let's grab this password again. Copy. Paste. Second 2FA. Paste. All right, we're now authenticated with our teleport cluster. Now we can run tctl apps ls, and we can see each of our applications. We take a look at that app subcommand. Nope, that's not the right one. Maybe it's tsh apps. Yeah, there we go. I can never remember when you're supposed to use tsh and t control. But we can do an apps login. We'll log into our, let's look at, what does the thing tell me to do? Our secret application first. Okay, so that's called admin. And you'll see that what TSH is now doing is pulling down the certificate information that we need to do the TLS handshake with the application, with the teleport proxy service, to be able to browse to that application. And now if we copy and paste the curl, we should be able to hit admin.html and we get the admin page back. The last thing we want to do is just take a look at our dumper. So that can just be our TSH apps login again. Dumper. And we're just going to get the same information back. Now, you can imagine if this was an API that you're working on, a Kubernetes cluster, you want to be able to write tests or something like that. This is a really good way to get that configured. And we can see all the same information that we need to. And we can also do an apps logout dumper. It's just going to remove our certificates, our keys, and etc., and clean things up so we no longer have access to it. So Russell is asking, is there a CLI command to check the version of the client and server? Now, you can definitely do a TSH version and check the client version. I don't think there is any way to get the server version other than a TCL status, which is going to give you the version here. But that would be great if I could just run like a, I guess because you can be authenticated against multiple clusters. Yeah. Definitely feedback for the teleport team. It would be nice to get a warning saying the client and server are different versions before getting really bizarre messages that don't make a lot of sense. Like, hey, failed to authenticate with a handshake end of file. Like, that doesn't tell me anything. It was just sheer chance that I remember the versions were different. So yeah, room for improvement there. But that's it. Thank you for, let me pop back over. In fact, no, the repo. So yeah, hopefully you enjoy this workshop. We've got another one coming on Kubernetes. Stay tuned for that. Check it out, run through it in your own pace. I will get the typos and random things that were omitted today, especially the IPv6 on the deny block for Nginx fixed, so that no one else has to run into that. And I hope you found it enjoyable. Teleport is a wonderful application. App Access has so many different potentials that make it just wonderful for exposing things like Grafana, backend portals, admin portals, etc. from your infrastructure in a secure fashion. So thanks for joining me today. I hope you have a good one, and I will see you all soon. Thanks a lot.